Hello and welcome back to another part of our molar calculation video that we just started, right? In the first video that we did was we just introduced into three formulas we used. If you haven't checked that out, please do check that out. I'll be giving the link of the first video in the description. We will be following through a simple practice workbook that I have prepared, and there are 6 questions. Each of the questions actually targets one thing at a time. We will be first equation deals with how to calculate the moles and mass from a balanced equation. In normally generally for Edexcel chemistry or O levels Edexcel chemistry or Cambridge International O levels chemistry, your equation is mostly going to be balanced, right? So you don't have to worry about dealing with balancing equation while doing the calculations, right? So let's get on into it and see what's happening in the calculation. All right. Okay. Now, to calculate the mass of iron produced 12 gram when 12 gram of iron 3 oxide is completely reduced by carbon monoxide. The equation is given and the relative atomic masses is also given. The first things foremost that you need to do when dealing with these calculations is underline the information which has been given. So the information of mass is given for Fe2O3. So let's just try to figure out the moles of Fe2O3 first. So mole of Fe2O3 is mass over molar mass. I'll just use a shorthand. Now, if you look into the mass given is 12 grams. And the molar mass of Fe2O3, we already know the formula and also the relative atomic masses, right? So 56 times 2, because there are 2 irons, plus 16 times 3. And if we do this calculation, what do we get? Actually, let me just do it in a calculator and then come back to you. 12. Sorry, my bad. The answer is 0.075 mole. Okay. Now, if this is the moles of Fe2O3 and we are asked to calculate the mass of iron, this is one of the important. So we need to have a relation between this one and this one. Okay, so if we look into the equation, we see that the mole ratio for Fe2O3 and 2Fe is 1:2. The mole ratio is 1:2 because I have 1 in front of Fe2O3 and 2 in front of Fe. Therefore, mole of Fe will be exactly twice than that is for Fe2O3. And if we do that, the value is going to be 2 multiplied by 0.075, that is 0.15 mole. Now you know the moles of Fe. Now once you know the moles of Fe, the mass becomes very easy because we can just tweak this formula that we got, and if we subject mass, the formula we get is going to be mole times molar mass. So your moles is 0.15 and the molar mass of iron, because we are asked to find the mass of iron. So the moles of, the relative atomic mass of iron is 56. We multiply with 56 and the value that we get is 8.4. 8.4 gram. So the answer is 8.4 gram. And this is one of the simplest way that we can actually deal with calculations where there is mass and moles involved, as well as the equation. Are we clear?